Designers using Civil 3D have the power to create great things. However, incorporating the ground correctly so that designs are solid, safe, and efficient is hard since the ground was invisible, until now. GeoDin Ground provides designers with insights below the ground, right in Civil 3D. This video provides an in-depth demonstration of GeoDin Ground. The GeoDin Ground app is used to import borehole data, such as coordinates, depths, and soil layers descriptions from a GeoDin database into a Civil 3D environment. Once installed from the Autodesk App Store, the app appears as a ribbon with a few buttons. Before import, let us have a quick look at where the data comes from. GeoDin, a geodata management tool, supports databases both in the form of Microsoft Access files, which can be stored either locally on your machine or on a network drive, and client-server SQL databases. Within a single database, several projects can be stored. For the demo database I am using now, just one project is included. Within a project, we have objects, such as boreholes or CPT locations. Documentations, such as logs and templates, can be saved inside the database, also at the borehole level, as denoted in this case by this yellow icon for these two boreholes. Borehole data is managed through two main methods: data management and measurement data. Under data management, the user can access general data, which record the borehole's metadata such as location and project name, depth reached, but also coordinates and the coordinate system. The layer description section allows the user to choose a standard for ground description from a given list. For each layer, soil properties are entered by the user and automatically translated into filled patterns and standard compliant descriptions. Groups of layers belonging to an overarching soil type can be described by the property ground unit. The sample section hosts a list of all the samples taken for this borehole. In the data sequence section, cone penetration test data and other depth soundings are stored. For laboratory and in situ tests data, we have the measurement data section. Here, GeoDin can host dozens of tables aimed at recording and processing data from geotechnical tests. For this specific database, the list of tests performed includes tests such as water content, triaxial, and rock quality. The full name of the test is visible in the ribbon below. Let us now import borehole data into Civil 3D. The button Manage Data Sources allows the user to add a database file to the selection of databases for import. By means of the button Select Data, a dialog window pops up, where you can select from a list of databases. Selecting the database opens the projects within the database. By choosing Open Project, you can visualize a list of all the boreholes within the project. With Show All Documents, you can directly visualize the documents saved in the database. By pressing Draw Boreholes, the locations are drawn in Civil 3D as Kogo points. With an additional command, GeoDin Draw Boreholes, currently entered in the command line but soon to be included in the ribbon, layer data is imported as well. Let us select a shaded setting to make everything more visible. As you see, the boreholes are represented as cylinders, and the soil layers, or better, the ground units, are displayed in different colors. On the left side of the boreholes, the borehole metadata is displayed, while on the right we have the ground description for each layer. By using the Layer Properties section, annotations can be switched on and off for the single borehole, or for all of them at once. The app also provides a command to draw surfaces and volumes between boreholes, allowing the user to create a model of the subsurface based on the soil layers. By clicking the button, a selector appears. By selecting a subset of the borehole domain and pressing Enter after such selection, the app interpolates between boreholes, drawing surfaces which connect upper and lower layer boundaries. It is possible to visualize the surfaces by turning off the visibility of the volumes in the Layer Property Manager. Finally, the single surfaces and the volumes can also be toggled on and off in order to isolate them for better visualization. This demonstration showed you the key capabilities of GeoDin Ground for Civil 3D. This app was released in the beginning of 2025, and GeoDin and Autodesk are committed to improving the integration of ground data in design, with either GeoDin Ground as well as with other innovations. We are working on calculations to know the volumetric information of the ground so you can accurately model the P&L of your project. Better merges of geophysics data are also on our roadmap to help you better plan your site investigation and save time, cost, and CO2 emissions. These are all steps we take to ensure that the entire industry, meaning multiple contractors like geotechnical engineers and civil designers, can work together in a safe cloud environment, leading to better designs and in a better build world.